All right, class, today we're going to move on to section 510. Now, we're still factoring, but we're going to see things a little bit different this time, okay? And we're going to learn a new method, completely new method, called factoring by grouping. Now, there's two real important properties that we've learned back in other chapters that will really help us today. And one of those first properties that we learned before was distributive property. Do you remember back in chapter 4 when we were learning how to multiply polynomials, and this is before we learned how to FOIL, that we could take our binomials and we could multiply by using distributive property. If you remember, we would take that first binomial and we actually broke it up into its parts, okay? And we would say 3x times the back polynomial, and then we've got minus 2 left, and we do minus 2 times 5x plus 7. Okay? And we use that a lot. Some people like using the distributive property method. Some people like doing the box or the vertical method. But that's a real important thing that we need to see as we head into the idea of factoring by grouping. Now, let's say we do it again, and let's use these pair of binomials. Remember, we're going to take that first binomial, and we're going to break it up into its different parts. And so we're going to take the first term, which is 5x, and multiply it by the second binomial. And then we take the second part there, and we're going to say plus 7 times 3x minus 1. Now, the other important thing that will help us, another helpful tool in recognizing factors, is we've got to recognize when factors are opposites. And this is something new for us. Now, who remembers back from, I think this was actually chapter 2, what happens if I multiply something by negative 1? If you remember, if I multiply something by negative 1, then what does it do? Okay? Basically, if I multiply something by negative 1, okay, it takes it and it changes everybody's sign. So this would be, again, if I took, and so we're going to use that idea of multiplying something by negative 1, okay, to change signs. Now, I want to show you something. We know that when I look at addition, addition is commutative, okay? We know we can switch the numbers. Oh, but we learned back in chapter 2 that order matters with subtraction. That's right. Okay? And so when I look here at this bottom example, you're going to see that n minus 3, okay, and 3 minus n are opposites. Now, order matters in subtraction, so when I have a minus sign in there, I can't just switch those letters and numbers places. All right, and so we're going to have to realize when we're doing the math here, when we're factoring by grouping, it's very helpful for me to recognize opposites, because I can take this second guy here, and if I multiply him by negative 1, what happens? Well, that's going to give me what? Negative 3 plus n. All right, and then if I rearrange the furniture, because addition is commutative, that's going to give me n minus 3, and now these are the same. Okay, and I'll show you what I mean as we go through and look at some problems. So we're going to find out when we're doing this idea of factoring with grouping and we have opposites, we can work through it by realizing I can multiply by negative 1 to change everybody's sign. So let's look over here and see how this is going to play out for us. If we're going to factor by grouping, and let's say they give me something like number 1, well, does that look a lot like the distributive property? And we know that distributive property or multiplying and factoring are inverses of each other. And so basically what we need to do here is we're going to realize, hey, these are common factors. We've got y minus z and y minus z. They're common factors, so I can bring that down, and that is actually one of my two binomials. Now, how do I get the next binomial? Well, we're going to take what's left outside and put it back together. And so that means we've got x minus 3. Okay? So see how this is the inverse or the opposite of multiplying by distributive property? We're taking those terms on the outside and we're funneling them back and putting them together. Now, it only works when whatever's in parentheses is the same. So let's look at number 2. If I look at number 2, well, did you notice we have a common factor? What's in my parentheses is the same. So I can bring it down as my common factor. I bring it down. Now, the second binomial is what's left out in front. Well, did you notice I've got an A here, and we've got a plus sign. Oh, but there's nothing there. But what's understood there? An understood 1. Okay? So again, we're using the inverse or the opposite of distributive property. Okay, we're taking the numbers that on the letters and the numbers that are on the outside of the parentheses, putting them together to make a binomial, and then bringing that common factor, that binomial that's the same, in parentheses down. Now, here's where that second idea comes into play. If you look at number 3, if I look at what's in parentheses, are they exactly the same? No, they're not. Okay, remember, these are considered opposites. Okay, order matters with subtraction. Subtraction is not commutative, and so they're not the same thing. So in order for me to get that common factor, I need to make these opposites look alike. And how I make these opposites, or what's inside the parentheses, to be the same, I need to multiply this by -1. Now, Mrs. Burton likes to call it that -1 thing, but if I take that and I multiply this second parenthesis here by -1, what are we going to get? Well, we're going to get -4 plus b, and now that it's addition, okay, it's commutative, so we're going to make this b minus 4. We just rearranged the furniture, and now do you understand that what's in parentheses now is the same? Okay? Now I have a common factor because I multiplied by -1 to take those opposites so I could get them to be a common factor. So now we bring down the common factor b minus 4. And now we're going to take everything that's outside and put it together to be the second binomial. Okay, so it's very important that when we're using this idea of factoring by grouping, we've got to check and make sure that what's in parentheses, okay, is a common factor. It's the same. So look at number 4. Do you see it right away? Yes, good job. Okay, these guys right here are opposites again. Order matters with subtraction, so in order to get these to look the same, I need to multiply this one by -1. Mrs. Burton calls that the -1 thing, and so that's going to make this -3 plus y, and so now I've got y plus, sorry about that. I've got y minus 3. I can rearrange the furniture now because I multiplied it by -1. We've got 3y, y minus 3. Do you notice I now have a common factor? There's my common factor. I can bring it down, y minus 3. And then whatever outside comes together to make the second binomial. Okay? But again, it only works when what's in the parentheses are the same, and if they happen to be opposites, like in number 3 and number 4, then if I multiply that second one by -1, I can rearrange the furniture. They're now the same. I have a common factor, and I can move forward. Now, sometimes, though, they kind of didn't do the distributive property for me. I have to take care of it. So they're going to give me something that looks like my term here. And again, did you notice we have 4 terms here? Okay, we have 4 terms. So when I have 4 terms, I'm going to look to see if I can factor. Now, here's what happens. We have to group our terms with common factors. Now, So that's why we call it factoring by grouping. Now, if you notice, and it almost always happens this way, the first two terms are going to group together because they have a common factor in red, and the back two terms usually come together, group together because they have a common factor in blue. And so if you notice from step 1 to step 2, I factored out my common factor in the first pair, which was B, and then that left me with A minus 2. I factored out the common factor in the back half, which was C, and now guess what? I have my common factor again. What's in parentheses is the same, so it funnels down together, and then what's left outside comes together to form the second binomial. All right, so let's see what that looks like for us as we go through and do a couple. Now it says factor by grouping and then check by multiplying the factors. So if I look here, again, there's no parentheses, common factors in parentheses, so we know we need a plan B. And so let's look. Did you notice that my first two terms have a common factor? They sure do. My back two terms have a common factor. So what am I going to factor out in the first two? What's common to both? Yeah, an X is common to both. So what's left in my parentheses? Remember, when we factor out that GCF, we go back and divide everything, so we're going to have X minus 2Y. Keep that plus sign in the middle. What's going to be my GCF over here? Well, did you notice I can factor out a 4? And what else can I factor out? A 4 and a Z. If I factor out the 4 and the Z, go back and divide both terms by your GCF. We have X minus 2Y. Hey, looky there. Yeah. Did you notice that I've got my common factor again? What's in the parentheses is the same. Okay, so what do? Remember, those two come down to be my common factor, and what's left out in front becomes my second binomial. Making sense? Okay, let's look at number 6. Look at number 6. So when I look there, they did, okay, the opposite of our distributed property isn't going to work because I don't have the parentheses with the common factors in them. So that means, okay, I need to group it myself and find the common factors. So if I look here, hopefully you notice that the first two have a common factor and the last two have a common factor. So if I look at the first two, between u cubed and u squared, what do we factor out? Yeah, that's right. We take the smaller exponent, and what do I have left? 3u minus 1. I need that minus sign in the middle. And then over here, what's my common factor? Well, my GCF is a 3, and what do I have left? 3u. And some of you are going to say plus 1. Hey, did you notice red flags waving here? That's going to change this to a minus. And so now I have like terms. So 3u minus 1 comes down. And now what's left on the outside? U squared minus 3 makes my second binomial. A little bit tricky, but if you can realize, oh, I've got common factors there, then that's what helps. Now, the hardest one that we're going to look at today is number 7. And again, if you looked at example number 4 on page 225 in your book, it really shows us what to do. Now, hint, hint, we've seen this before, okay, back in section 5-6. So when I look at number 7 and I look there and I think, well, there's 4 terms and I agree. But did you notice we don't have a common factor between the first two? And we have a common factor in the back two. But so even if I factored, it's not going to work because I have to have, if I factor by grouping, I'm not going to have the same thing in the parentheses. And for grouping to work, I have to have that common factor that matches in the parentheses. So the idea here is sometimes, okay, instead of factor by grouping, we may have to regroup something, okay, regroup something to get one of those trinomial squared. Remember those back in section 5-6? And so hopefully, if you can recognize that, I can actually put those guys together. And this is actually a binomial squared. How do I know? Is the first one a perfect square? Yes. Is the last one a perfect square? Yes. What sign goes in the middle? And this is going to be 2s. Now remember, we have to check the middle to make sure that it's a binomial squared. Remember, we check the middle by doing that 2ab. So we've got negative 2st times 2. Remember, we multiply these two guys together, and that gives me negative 4st. So the middle checks. So this is a binomial squared. Now, I like to call this, when I realize that I can't factor by grouping and I've got to look for that trinomial squared, remember I told you you're looking for an odd man out. Odd man out. And when I look up here, okay, p squared doesn't go with anything. Okay, I've got t, st, s. Okay, so the p squared is like my odd man out. So now let's bring him down, and we've got 9p squared minus my binomial squared. Oh, do you remember what this is? Special pattern. Okay, this is difference of perfect squares. Is this one a perfect square? It is. This is a binomial squared, so we're going to say 3p plus t minus 2s. Okay? This is my sum. And now we need the difference. Remember, when we factor a perfect square, we need sum and difference. So this is going to be 3p, and then it's going to be minus, and then we've got t minus 2s, but remember that red flag's waving there? That's going to change this here. So this is my sum, and this is my difference. Now, guys, that's the second time around on that one. And again, we got to really pay attention and make sure we look for it when I realize there's an odd man out. Okay, so you may now begin your homework.